Painting wet on wet, really? Exploring the myths. Do your friends still joke that you go to work simply to watch paint dry? If so, this article may be what you've been waiting for, literally. You wouldn't be watching paint dry if the products you use could be applied wet on wet. Let's explore some myths and concerns surrounding the alleged witchcraft behind applying additional coats of paint before the previous coat has dried. Number 1, if it worked, people would have been doing it centuries ago. You're right, they have. The technique dates back to Baroque times, and even has a nickname, alla prima, first attempt in Italian. Although it was first used in oil painting, it has developed into a popular technique for concrete sealers, paper coatings, and linseed oil coatings. Number 2, if it worked, everyone would be doing it. Right again. It's especially true in the auto industry. They apply multiple wet coats, and the clear top coat is generally always applied wet on wet. The obvious advantages are reductions in energy costs, due to fewer bake cycles, and a 20% reduction in production time. Using similar principles, the auto industry claims to have pioneered the wet bed technique, which involves spraying a reducer or clear base coat prior to the primer application to help with surface wetting and edge blending. A not-so-obvious benefit of this process is said to be superior gloss. And don't forget about fewer heaters and other equipment to control ambient conditions. Number 3, that's great for the auto industry, but I work in bridge, or oil and gas. Hold your ponies, you're probably already applying wet on wet. If you stripe coat edges, welds, bolts/nuts, and rivets, on older structures, as the specification often says too, and then apply a full coat once the stripe coat is tacky, you're applying wet on wet, known as wet striping. In addition to improved coverage, wet striping produces a tacky surface and the subsequent full coat application theoretically adheres better. Number 4, the risks outweigh the benefits. How's this for a benefit? Imagine the potential for increased adhesion between coats with the availability of reactive bonding sites present in an uncured coating film. It would be long-awaited vengeance on the dreaded amine blush. Various patented polymer technologies use unreacted surface components to their benefit inside and outside of wet-on-wet applications. Certain two-component materials including urethanes can be heated in order to uncap polyols or other previously non-reactive sites, and are often followed with a coat of epoxy. Now there's a role reversal. So throw away your sandpaper, and forget about intercoat contamination. That's nothing to shake a paint stick at. Number 5, speeding up application could adversely affect performance of the coating system years from now. Maybe not. A paint manufacturer or a coatings testing laboratory can evaluate comparative coating system performance by applying coating systems wet on wet and under normal intercoat drying times, then subject the coating systems to accelerated corrosion resistance, accelerated weathering, thermal cycling, perhaps a variety of physical tests depending on the intended service environment, and even evaluate barrier properties using electrochemical impedance spectroscopy, EIS, to determine whether performance of the coating systems are affected by wet-on-wet versus wet-on-dry application. Number 6, but I want to measure the dry film thickness of each coating layer. That presents a problem. All coating thickness gauges require contact with the coated surface, so underlying coats must be dry before they can be measured. So if you want wet-on-wet, you'll have to rely on wet film thickness measurements or the total system thickness once it has dried. You can't have it all. There aren't a large number of products on the market that claim to possess the wet-on-wet application feature. Historically, the only industrial applications of wet-on-wet coating application have involved 100% solids products. However, there are an increasing number of products that weigh in at 50-65% volume solids. Here are a few generic references to wet-on-wet applications in the industrial market. In a recent disruptive development, one manufacturer announced the release of its proprietary process which allows their products to be applied wet-on-wet. At 65% volume solids, it is a step in a new direction from the customary 100% solids products. Initially developed for use on offshore oil and gas assets, the application process minimizes the potential for intercoat contamination and includes the added benefit of carbon nanotechnology, leading to its integration in many industrial market sectors. Another manufacturer produces a high solids epoxy primer that is formulated specifically for wet-on-wet application. It is typically paired with a urethane topcoat, and is primarily used on industrial equipment, building materials and agriculture equipment. Yet another manufacturer produces a one-component primer system that allows the top coat to be applied wet on wet and is used for industrial applications. Finally, high-ratio calcium sulfonate alkyds, HAR-CSA, are used for overcoating lead-based paint on bridges and a variety of other structures. They are applied by a wet-on-wet process that involves a penetrant, then caulking of joints and spot priming, followed by overcoating. In fact, they remain soft and impart minimal stress on the underlying aged coating system. In conclusion, don't count your chickens and rule out an application technique just because it sounds too good to be true. Could watching paint dry ever become a thing of the past? Since only a limited number of products available at this time, it's unlikely that it will be anytime soon. But the possibility exists. This article was written by Carly McGee, KTA's Materials and Physical Testing Laboratory Supervisor for KTA. Thank you for listening.